Hi, welcome back. I'm Nisha. Today we are going to talk about how to implement stack algorithm in static method. Static means using arrays. It's a fixed size memory allocation. It's a lengthy video, so I make it into 3 sessions. So session 1 is push operation. So in the last video we already discussed about what is stack and about push and all theoretical part we discussed. If any doubt, please click on the link I put it in the description box. Just I'll show you one example. See, it's a normal array and its name is stack. See the elements we stored in that array and the maximum size is 8, 0 to 7 are the index numbers, and see top. It's a normal variable only. But why top? Because stack is a LIFO concept, last in first out method. So only one ent is there, one open area is there to insert and delete the elements. So top is controlling the array for insertion, deletion and retrieving and for every operation. So this is what stack. Okay. So let us start with push operation. How to implement this push operation. So stack LIFO last in first out method. So how to implement the stack using array. So I put some important points. Okay, just see this first point. Initially, the value of top I already discussed. Top means it's a normal variable. So initially means first time, the value of top will be set to -1, -1. Why we are setting into -1? To denote the fact that the stack is empty. Understood? Here the top is 5. Is it? Top is focusing on the fifth element. Is it? Yeah. If it is -1 means the array is empty that time. So just to denote that, we are setting the top value as -1 first time. So initially the value of top will be set to -1. Clear? Now see the second point. Whenever an element is added or inserted into the stack, the value of top will be incremented by 1 until it reaches the highest subscript of the array. So whenever an element is added to this array, the top is incrementing by 1. So first time it is -1, then 0, then 1, 2, 3, 4, 5, 6, 7. So this is the highest element, highest subscript, highest index number, is it? So up to that, we can increment the top. So that is the point here. Whenever an element is added or inserted into the stack, the value of top will be incremented by 1 until it reaches the highest subscript of the array. Understood? Now the third point. If an array stack of n elements is used to implement a stack, the values of top can be vary from 0 to n minus 1. Is it? N is the element here. And here I put example as 8. Okay. So 0 to 8 minus 1, that means 7. So here, if an array stack of n element is used to implement a stack, the value of top can vary from 0 to n minus 1. Okay. And the elements in the stack can be referred as, that we already know. Is it? Stack of 0, stack of 1, because stack is the array name. So stack of 0, stack of 1, stack of 2, like stack of n minus 1. So this is the way of storing. Okay, this is the way of expression. Stack of 0, stack of 1, stack of 2. So these are the important points to remember when you are using a stack application. Clear? Okay. So push operation using array. So let us see the important points for this push operation. Okay. So first we want to accept the value in a variable to insert into the stack. So first we want to accept the value in a variable for insertion. Then the second point is what? Increment the value of top. Top is the variable that we want to increment by 1 because top is -1 first time. Is it? So if we want to increment by 1. Then store the value at the top position. So where the position of the top when we are incrementing by 1, there in that position we want to insert that inserted value. So these are the steps we want to follow for push operation. First we want to accept the value in a variable, then we want to insert into the stack. So increment the value of top first time, then store the value at that top position. So these are the 3 steps. But see, the above steps are valid only if there is a free space for insertion. Yeah, if there is a free space, we can insert it. If there is no free space, it is impossible to insert the elements. Is it? See, once the stack is full and if we attempt to insert an item, an impossible situation is arises. This is known as stack overflow. Understood? What is stack overflow? If there is no free space in the array, if we are again inserting the elements, if we are attempting to insert the element, it is impossible. So that situation is known as stack overflow. Understood? So this is the important points, or we can say this is the procedure we want to follow for the push operation. Clear? Okay. Now we can check how to write the algorithm of push operation. So before moving into algorithm, I'll show you one example how the push operation is working. So this is the array here. There is no elements in that array. So first time we set the top as -1. Okay. So now new item came for insertion. So item 5. So first we want to increment the value of top. Is it? So top is 0 now. Now we want to insert that element in the top position of that stack array. Now see this? Yeah. Top position, that is 0. So top is focusing on 0th position. We inserted that element in that position. Got it? Now next item came, that is item 4. So first we want to increment the top. So top is 1 now. So now we want to insert the element 4 in that top position. Top is focusing on 1. Clear? Now the next item came. So top is incremented by 2. Now we want to insert that element at the index number 2 position. Top is focusing on there. Clear? Now the next item came. Item is 1. So top is incremented by 3 now. See? Incremented to 3. Now array we want to set it as 5, 4, 6, 1. See? 1 is in the top position. Clear? Now one more item came, that is 12. See, top is incremented to 4. Now array is focusing on, top is focusing on index number 4 now. This is the highest subscript or index number, is it? If one more insertion came, what to do? That is impossible situation, is it? Yeah. So that time we'll get a message overflow. So this is the protocol of push operation. Got it? So top is controlling the array. So if the top reaches on that highest subscript, next insertion time we'll get a message as overflow. Got it? So this is the working of push operation. Now let us move on to the algorithm. So here this is the algorithm for push operation. Just see this. Top is the variable we use for focusing that array. Then n is the maximum size given for that array. Then stack is the array name here, and val is the input value we are assigning. Okay. Now see. Step 1 is stat, and step 2, if top is less than n minus 1, n minus 1. Okay, n is the maximum size. So here see the example here. N is the maximum size means 8 is n here. Okay, suppose 8 is the value of n. So n minus 1, till n minus 1 only we can insert the elements. Is it? 0 to 7 we will get space. So if it is less than 7, then only we can insert it. So that is the condition here. If top is less than n minus 1, then, so there is a space. So then top is equal to top plus 1. So we are incrementing the value of top to the next index number. So we are incrementing it by 1. then we can store that value. Which value? This is the value we are giving. So this value we want to store it in that array stack in the top position. So stack of top is equal to val. Okay, else that means the top is equal to n minus 1 now. Top is equal to n minus 1. That means top is on the 7th position. So there is no space there. So we can say else stack overflow. So print stack overflow. End of it. Now we can stop it. So these are the steps. It's very simple, is it? There's only to remember that we want to check the space is there or not. So how we can check the space availability? See, top is the variable here and n is the size. If top is less than n minus 1, there is space. So we can increment the value of top by 1 and we can store the value at that position. So how we can store that position? Stack is the array name. Stack of top position, that is equal to val. This is the way of insertion. But if top is equal to n minus 1, so top is focusing on the 7th now, that is equal to n minus 1. N is 8 here, is it? In this example, n is 8. So 7. If top is on the 7th position, there is no space. So else print stack overflow. Understood? End of it. Stop. So this is the algorithm for push operation. Clear now? Okay. Now we can check how to write this function in C++. So now we can check the C++ function for push operation. Okay. So the variables top and n are assumed as global variables. So we already know what is global and local. So top and n are global variables. Okay, to perform this push operation. So here see void push. There is no return type. So void push is the function name and in bracket 2 arguments are there. One is int stack empty square bracket. That means we are passing an array. So array stack. Okay, this is an array. Then the second argument is int val. So this is the item we want to insert it in that array. So these two we are passing from the calling place. Okay. So main we didn't define here. So that I'll show you in the session 3 part. This is only about the push operation. Okay. How we can write the push function. So in detail I'll show you in the session 3. So 2 arguments we are passing from the calling place, that is from main. So one is array and the other one is that insert value. Okay, now brace open. If top less than n minus 1. So top, n, these are 2 variables, but we didn't declare it here. These are global variables. Okay, that is in the way we can declare that global variable just above the main, not inside any block. Okay, so if top is less than n minus 1, that means if there any space or not, we are checking the space. Top plus plus. If it is true, we are incrementing the value of top plus plus. And we want to insert that val to that position. So how we can insert? Stack of top. So stack array of the top position is equal to val. So that value will insert at that position. If there is space, we can insert it. Otherwise, so else cout overflow. So if there is no space, we can say overflow. Understood? It's a very simple one. Only thing, this is push operation only. Okay, this is the push function. So we are passing stack array and the value which we want to insert it. And the method inside that function is what? Only we want to check the space availability. So how we can check it? If top is less than n minus 1 or not. That means there is space. If it is true, there is a space. So we can increment the value of top and in that top position, we can insert the element. Got it? Otherwise, overflow. Clear? So see the example here. First time top is minus 1. So we are inserting the element here. So 5 is the first element. So val is 5 and stack is array. So we are checking top is less than n minus 1 or not. N is 8 here. Is it? Top is minus 1. So it is less than. So we can increment the value. So top is 0. So on the 0th position we can insert it. Stack of top is equal to val. 5 we can insert. Again the next element 4 came. So we are incrementing the value of top to 1. Then we are inserting. Then 6. Then 1. 12. 34. So again 2 more spaces there to insert. If top is reached on 7, there is no space. So that time we will get overflow message. Clear? This is push operation. The same function itself I make it in a different way. See, just see this. This is same like what we discussed in the last slide. Now see the difference here. Void push itself, stack and val, array and val. These are the two arguments here. And we are checking. See, if is full, is it full or not? Is full. So we can use this function for checking the array is full or not. Okay, if it's full, we can see out a message overflow. Otherwise, else top plus plus and stack of top is equal to val. But this checking, we can make it inside that isFull function. See, I'll show you here. isFull. Int isFull. Okay, int, return type is there. Int isFull. There is no argument here. It's empty. So we are checking if top is equal to n minus 1. Top is equal to n minus 1 means top is, just imagine that example, top is 7 or not. If top is equal to 7, return 1. That means it is full. It is true. So return 1. Else return 0. So here we are checking if is full, yeah, we are getting 1, return 1 value here. That means if 1, that means it is true. So we can print that message as overflow. So this is isFull function. So this also we can apply it on this. Okay. Otherwise, this checking we can write it in the function itself, push function itself. So if you do it in the function itself means just if top is less than n minus 1, top plus plus and stack of top is equal to val, else overflow. But here for this condition, this we are calling that function isFull or not. So in isFull function, we are putting that condition. If top is equal to n minus 1, that means it is full. So we are returning the 1 value. Okay, if it is 1, that means the condition is true. So we will get overflow. If it is 0, this condition is false. So it will move on to the else portion. So top is incremented and stack of top is equal to val. So in both method we can write this function. Got it? So if we are defining that isFull function, we can use it for some other functions also. Okay. So both are for the same purpose only. So isFull, by applying isFull function also we can use it push function, or directly we can give that checking part in the push function. Understood now what is push operation? Okay. So the session 1 is only about that push operation. I hope you all enjoyed it. So in the next session I'll show you about the pop operations. Then in the third session we can combine all the functions: push function, pop function, peek function, isEmpty function, isFull function and the main. Okay. So till then, take care. Bye. Thank you.